Who has familiar at least with JavaScript 6, or what's sometimes called ES6? A few people here, okay. The language spec for JavaScript 6, it's technically called ES 2005 nowadays, has just sort of been finalized, and you're going to start to see these features in browsers, being introduced in browsers. The one that I want to call your attention to today, and the one maybe if you've got a really new version of a browser you might actually be able to use, is JavaScript now has a new shorthand syntax for function, so that you can take this and convert it into this. Much, much nicer. So today we are going to be writing a lot of functions. So I happen to know the latest version of Firefox supports this. So if while I'm talking here you want to go and download Firefox, because later we're going to be filling out interactive exercises, I think it would actually help you because you can use this arrow function there. Now you can always use Chrome if you want to, whatever you're comfortable with. I believe the Canary of Chrome may also support this already. So shorthand for writing functions. I'm just going to go through that one more time. You can get rid of all the boilerplate and just write it like this. So we'll come back to this, but yes. So that is the end of the JavaScript 6 tutorial. That's all you need to know for this particular presentation. So first function of 6 that I'm going to be teaching you today, for each. Who here has used for each? So you'll notice the next few functions I'm going to be showing you are all on arrays. In fact, today we are probably not going to get to covering any asynchronous programming whatsoever. We are going to be doing what I like to call wax on, wax off exercises. We are going to learn something which might not seem as if it's related to asynchronous programming at first, which is how to program without loops. Let's say today that if I was to say, you can't use any loops when you go into work on Monday, could you still get your job done? No while loops, no for loops, no do while loops, no cheating. How many of you feel like, yeah, I could probably get my job done? Couple people out there. But generally, I think most people are pretty comfortable using loops, right? We might be lost a little bit if our programming language didn't have loops. Well, when you start doing async programming, that's exactly the world you're in. You can't repeat an asynchronous function with a loop. And I'll explain a little bit more about that later. But that's effectively the world that we're in as soon as we start doing large asynchronous programming, large asynchronous programs. Loops become useless to us. So we need to find ways of repeating actions, right, and processing streams of data as they come in without using loops. And this is what I'm going to be teaching you guys today. Programming without loops using just a few simple functions. So what for each does is it takes a function and it applies that function to every item in an array. In this case, I'm just printing each one of these items to the console using console log. That's relatively straightforward. You can, if you want, you have a JavaScript interpreter up right now. Maybe in the console you can play around with that very example yourself. If you don't, unfortunately, if your browser doesn't support the arrow function, you got to write it the long way. Function x, return, you know. Next, I'm going to introduce you to the map function. The map function is similar to the for each function, except the difference is what map does is it takes a function and applies it to every item in a collection, creating a new value, and then creates a new array with all the results of applying that function to each value in the array. So map does not change the array. And I want to call your attention to this notion, this thing very specifically. None of the functions I'm going to be showing you today change arrays. What they do are create new arrays. So what I'm going to do is I'm going to apply this function to every item in the collection and create a new collection containing the results. So if we run this, we get 2, 3, 4. So we didn't change the original array. We actually created a whole new array. So if you ever want to transform every item in a collection and put it into a new collection, map's the tool for the job. Next, we're going to talk about filter. Filter is very similar to map. It's going to apply a function to every item in the array. The difference is this function is a test function. Instead of transforming the value, it's going to apply a test to every single value. And only if that value passes the test will it make it into the new collection. So here, if I run this, we actually get an entirely new array. We didn't change the original array. I'm going to keep hammering this point because it's really important. We haven't changed the original array. We've just created a new one with only those items that pass the test. Does that make sense to everybody? Great. There's a quick question here at the end of the current section. Will ES4, I guess I can talk about this later, but for of lists, we'll talk about that pretty soon. Concat all. So concat all is not in JavaScript. It's a function we're actually going to write later on and add to the array object. But what concat_all does is very simple. It takes a multi-dimensional array and flattens it by one dimension. So in this case, we've got a two-dimensional array. And if I run this, it's going to get flattened into a two-dimensional array. Now I want to call your attention to something. It's going to be important later on. Notice what happens to an empty array in a two-dimensional array when it gets flattened. It just disappears. You take an empty collection inside of a two-dimensional collection and you flatten it, that empty collection goes away. We'll see why that's important later on. So quick review, map, filter, concat_all. One thing I want to mention is concat_all will not recursively flatten deep collections. If you have a three-dimensional collection, it'll turn it into a two-dimensional collection. If you have a five-dimensional collection, it'll turn it into a four-dimensional collection, and so on and so on. It doesn't recursively flatten n-dimension collections. So map for transforming every item into an array, every item in an array into a new collection. Filter applies a function to every item in an array, and only if it passes the test does it make it into a new array. And concat_all flattens multi-dimensional collections by one dimension.